Thank you. Thank you, Mike. First of all, thank you to the Tech SEO group. I mean, JR, Patrick, I mean, all the guys, and so many I forgot, right? That putting so much effort. It's always so many little details here and the thought behind it. So I really want to thank you guys, really. All right, so my talk today is going to be a little bit different. And I'm actually going to talk about some of what you probably want to see behind the scene. And we'll start actually with that, right? Like, things became a lot easier, right? We can build whatever we want. We have Lovable. Look how quickly they went to $100 million, right? Unbelievable. You come with Lovable, and you come to your boss or your client, and you show them a prototype, and they're all happy. We've got LLMs, so we can actually develop software faster, and things have become a little easier. But the truth is that the pace by which the AI capabilities are actually increasing and the ability to use them is very different from the curve that we've seen in the adoption. And perhaps the people in this room are more, I would say, in the different slope, a little higher, but I gotta tell you, the pace that is actually happening with the AI capability is very fast. And like with everything LLMs, they're as good as the data that are being trained on. So when you're thinking about it and you put that in mind, and I'm going to show it a few examples, it's really important to think about what's inside. Data, as we know, it's probably our most important currency as SEO, and we have to use it every day in many things that we do. When I first got into SEO, we had this thing that we called it, when we're building products and dashboard, the garbage in, garbage out principle, right? You're going to put some bad input. Most likely, you're going to believe some bad output. The thing is, now we introduce a new friend, which are these models. And the thing about these models is that if you're not going to use them properly, or you're not going to train them properly, what you may end up having is actually some hallucination, some maybe answers that are plausible, or I call them the excellent student that you may get. And for us, it's like giving you probably a bad insight. And so the truth is that to build that trust behind the data in 2025 became so much harder because the pace and the amount of data that you actually need to process these days is far greater. And the amount of change that we see, right, is so greater that it's really hard sometimes to keep up. And I'm going to give you some example, probably that many of you may have had some question mark, and you might be familiar around first-party data when misalignments exist. What you see in this curve is something we kind of because we have access to a lot of different data sets, we are triangulating the view between GA and GSC. And what you see here is essentially us plotting the ratio between GA of what it reports at a high level, search traffic versus the number of clicks you're going to get from GSC. And so in an ideal world, right, those two things should work, right? They should be exactly the same. But it turns out that they're not. And there is an absolute ratio that we have been modeling it and actually been using it to inform many things in terms of the differences that we get between clicks to keywords and a site traffic that we are going to report on. And so the truth is that this relationship, in many ways, is something we can actually rely on and use them when we're actually looking at the data. And it turns out that actually SEO platform, and especially if you're dealing with a lot of different multi-channel type of data set, we've been living this world of handling uncertainties so much that this is part of our almost DNA, right? We collect so many different data sources that we got to start making sense of them. And the changes are so quick that we have to be able to adapt also very quickly to them. Just think about the modern SERP, right? Like how many times there are so many little items that are happening on the SERP, and sometimes the same items are showing in different orders within the SERP. And so we got to keep up with actually all these changes that are happening And one thing is very guaranteed, that there will be a change. We just don't know when, and it's going to happen quite a bit. So we need to be able to take this lack of predictability and sort of cook it in the way we're doing it. One principle that we take in everything that we do is called triangulation, right? So it's not enough for us to sort of like just detect the change and see that it's actually happening. What's important for us is actually to triangulate every data set that we're going to bring in, right? So we cannot have extra bias behind a particular person in a panel, because that's going to be an issue. We also cannot necessarily rely on a model that cannot be validated with real life. And so these particular principles, and also, of course, I'm going to show you an example on learning sets of what are the things that you got to pay attention when you're playing and trying to construct a picture of what the reality is. The problem for us, and it's going to be a problem for many of you as well, bringing more data, is how do you do it at scale in a cost-effective way? And this is our life every day looking and doing it. So what I'm going to do in the next few minutes, I'm actually going to take you through some examples, and it's going to be sort of like a build-up, and I'm going to walk you behind the scene on some of the approaches that we have been taking in some problems in delivering some of the metrics that you kind of like rely on, and you think like, oh, that's kind of like given. But what goes actually behind the scene in actually making it, and how do we adapt, how do we train, how do we adjust, and actually how do we validate, right, certain concepts so that you get actually the data that you can trust on. So I'm going to start with probably something well familiar, zero-click. This is our world, and in a world of traffic becoming like a maybe, and a CTR curve that we all are proud of our CTR curve, most likely is the most moving things that is really hard to understand what's happening, and coming with an ROI to your content also is becoming an issue. So how do we handle this thing, right? The way that we handle it is basically every SERP item is having what we call a zero-click curve. And it has a marginal contribution into the particular way that people are actually seeing it. Now, each one of them has a marginal contribution to the zero-click, and what we do is we then triangulate this with what people are actually doing, because we're able to see them behind the panel, what keywords they search to what URL they actually went to. And that on its own allows us to create what we call a keyword to URL ratio, which then is constantly adapting. In fact, we have it for every single item, and it's constantly changing in terms of the magnitude that it carries behind each one of these SERP items, because guess what? Many times, the order is actually changing. So whatever the keyword is actually a person seeing, the marginal contribution to the zero-click behind each one of these items also has to adapt itself to what actually people are doing, and then we validate it with the truth of actually seeing what people are actually clicked. So a lot of thinking goes behind this thing, and it's got to update itself almost to close to a real time, because the reality Google constantly change. So that's a big part to what we do. So what you can take from here is like one way to think about adaptation, and adaptation regularly on a regular basis. You have to be able to go and triangulate it. For us, it's real user verification. And then from there, we're able to actually get better estimation, which we still validate when we go actually to those GAs and GSC. So it's not enough for us. Okay. So I'm going to take you now to sort of like a bigger sort of like approach, and how we approach LLM a little bit. And now working actually with LLM can become like super expensive very, very quickly. And the art for us is actually how do we do it in a cheap way, right? Not cheaper, but cheap way, right? So that we still maintain some of these principles that I just mentioned. So I'm going to walk you through an example. And the example here is what we call line of businesses. Essentially, imagine that Carter is one of our clients, and Carter wants to basically model the amount of traffic that it gets and its market share against the full market to that line of business. So they're selling, babies and kids' clothes. And a typical competitor for them would be, children place. But actually, their biggest competitor in this scenario is Walmart, the kids one. The thing is, we want to be able to bring them that line of business so they're able to benchmark themselves against a true competition, because when they come and put those reports in front of their boss, they want to do it. So what do we need to do? We will actually need to split Walmart to the line of businesses for a taxonomy that we already have and predefine. And then go page by page, actually, and classify it to the line of business. And so we have about 100 million pages to process a day. This is too much, right? Every single day, we're going to have to do it. So we got to be a little bit smarter about how we're going to go and use it. Well, it turns out, actually, the big website are fairly good SEO, and they actually have enough clues that they exist within the URL. And yes, there are cases by which the URLs do not exactly match what you get inside the content, and we know how to deal with those. But in general, this is a good approach that we're taking. Now, when you're facing a problem and you're trying to solve it for an LLM, right, we take sort of like a three-step approach. The very first step, we're asking ourselves, okay, let's try to pick the best LLM version that exists at that point in time, and actually go and see if it's actually feasible to do it. In this scenario, we take all these list of actual URL, and we're trying to see if it can actually match it to the line of business that we gave it, right? Now, if the reason we do that is because we're asking ourselves, is LLM really going to be the right answer for us? Because it may be that it's not the right answer for us. So if it's actually possible to do it with the strongest LLM, it gives us some level of confidence of what the truth could be. And so what we did here, we're trying to basically manage these three things: the accuracy, of course, the cost, and the speed. And this is sort of like the thing that we are approaching it. Now, what we got here, okay, we got great accuracy, great, but this is too expensive to go and do that. In many cases, actually, we end up actually sometimes going to the traditional way, generating code that actually could do it, because we know what it would cost us. We know how much time it will be, so it's fairly predictable to get there. So I would say to you, when you're thinking about approaching something with LLM, the first thing I would say to you is make sure that sort of like if you're going to take advantage of the big model, ask yourself, do I really need the LLM? The next thing we do here for classification, for example, there are certain jobs that you don't really need an LLM, right? LLMs are, the advantage that you have them is actually understanding the language, which is what is the key thing that you're going to get out of them. So we say, okay, so using this language model, what we're going to do is we're going to create these sort of embeddings to those URLs, and we're going to create a similar embeddings into these line of business, and then sort of like apply it into a simpler classifier. In this scenario, we did it with a cosine similarity and trying to find the smallest distance possible so that it will actually match to be a kid's clothing. And so for us, it's cheap, it's easy, we can get it fairly quickly, it doesn't cost us that much money to generate these embeddings. The problem is when we're looking at this step, we got some fairly good accuracy, and the cost, of course, is much lower. And so we're asking ourselves, okay, what should we do now, right? And here what we do is we basically move into what we call a funnel of the optimization, right? Which is a series of activities that we're going to take to try to find the cheaper approach that we can in breaking the problem. So the one tactic we use in this scenario is called distillation, right? We say, okay, let's take the first part. Where was the problem? The problem was generating the proper embedding to those URLs, right? So we said, okay, maybe we should take an approach that is using sort of like a small language model, and we're taking sort of like a smaller network that we can have better control, right? And so what you have here is a very common tactic. It's called the teacher-student type of tactic, where the teacher itself is like training the student. And the teacher is the strong LLM, and the student has basically a basic, what we call a transformer. And all we need to do is to be able to show it enough example, and this way we will train it to actually do the job. in this distillation process, what we took is we wanted to actually go and fine-tune this particular training, and we use sort of a method that became really popular. It's called low-rank adaptation. What it does is it's injecting different weight, right, into these parameters in this sort of a small language model, and we only need to control it. The thing is, when you're using an expensive LLM, the latest, greatest, you don't have the same level of control that you could. So by distilling the problem to how do we control this particular weight, we then are coming to a place of like, okay, that is what we need to define, is we need to define this particular weight. Okay, so how do we determine the weight? Because the weight is what is really going to be the thing that we can actually go there. And here we're using something called this triple loss function, that it basically minimizes the distance between the example. So if you take a good example, for example, here what I show you, Apple iPhone 16, it is belonging to a line of business of phones. So I want to make that distance really, really closer. And if I put the same URL and I try to basically put it in terms of shoes, I want to make it actually more, the distance much larger between them. And so this is the process we take by providing these different examples and then training those weights until we get to a place where we're happy. The weights are good enough, and that's what we insert into that student. And now all we got to do is to take care of actually creating proper URL embeddings, right? That essentially help us get to a better accuracy. So what you want to take from these sort of like thinking when you're going to bring this is essentially two things. One, you want to distill the process, right, to the places by which you want to optimize the network itself. And second thing is thinking about the funnel like engineers almost, of like, what are the exact places that I absolutely have to go and optimize? When you start to think this way, right, it helps you sort of like approaching a problem. And you may decide that you don't need a very expensive LLM in this scenario. Okay, so you're dealing with a lot of different large data set and more data set. They're introducing complexity. And large data set, they're not very fun always to work with because you have to go and collect them. People want them very quickly. They want it sometimes on a daily basis. Sometimes they want it immediately on demand. And every complexity that is sort of like introduced, it's kind of like it's compounding itself when you're thinking about it. And I get like sitting in product, I speak to lots of different SEOs, and they're like, well, I just need this one more, pivot in this particular information. And why can't you like help me get this pivot? Well, when you're thinking about like a huge set of data that you're going to process, sometimes it's an easy one, but sometimes it's a difficult problem, and it's only sound like a really basic filter. That's all I need, or I need another sorting on a particular thing. So it's okay. We as SEO are actually asking more. We're embracing it, okay? And we actually going to need to go and operate in this particular way. Not only that, we are actually moving to a place, of course, that we're all trying to optimize to new types of metrics that hasn't been necessarily always top of mind for us. And we said, well, visibility or ranking was a great system. It told me I'm ranking in a particular place. Google decided that I'm relevant. It's all great. Here we move into a world. Am I there? Am I not there? Right? Who else is with me? Does it make sense that I'm there? Right? And so we are kind of like broke the entire view, and we're getting a lot of concerns about it. So I'm going to show you how we're dealing with an interesting problem, which is brand detection. Very basic. I just want to find brands and how we're using LLM. In this example, actually, I'm going to show you how we play with prompts, not so much playing essentially with embeddings, as I showed before. So what's the problem? You put in your request, you get an AIO, and now we need to extract the brands out of it. You can imagine this is also, of course, something else that you would see in ChatGPT, in all of the other LLM that we all are trying to optimize our presence. And it's interesting because we want to make sure that we actually, in this scenario, just wanted to extract the brand. Nothing else, just the brand. That's all I really care. To put this in context before I dive into what we did, for us, if we had to do it once a month, 33% of search queries have AI overview in them, right? And so that's about 100+ million AIO paragraphs that I have to go and actually process. Each AIO processing is going to cost us about 1,000 tokens. We're talking about $100 billion, 100 billion tokens to just process one thing, extracting the brand out of the AIO. And so if you're now going to add more models and new LLMs, you just have compounded a whole different thing. So we go back to the same type of activity, same exercise. Can we actually go and put this in the strongest LLM we can? And if we succeed, then we know we've got some good results. But we already walking into this problem, we knew that we are going to have to optimize because it's very clear to us that we won't be able to get that. The other piece is we're going to have to do it what we call in a batch, sort of like an offline, because if you think about all the different places by which your brand is showing, it's going to have to be processed all the brand, and you want it on demand. You want the answer, oh, I want to know exactly where all my brands is actually showing with all my AI overview results. And so we take an approach here that sort of, let's test it on the big one. So we create different queries. I'm sticking here to AI overview, but here's an example, car owned by Harrison Ford. And guess what? The wonderful strong LLM at the time that we did an amazing job and actually got exactly the brands we needed. We then plays with other one. Again, we're getting some really good things. So it's really hard to break for us, really hard to break the great LLM, right? They're really good in what they do. In fact, if you pay attention at the beginning, I showed an example about apples, and we asked them to actually extract brand behind apples. It only found one brand, which is true. It's Pink Lady. All the other ones are varieties of different apples. So it's kind of like really, really important that we understand what is good. We only broke it in this case where we gave it a partial answer from the AIO. It wasn't actually able to do it. Okay, so we know what's good in the best one. And so then we move into a place by which we take a more degraded version of the same model. Sometimes we even might go into a different model, but we know it's not as expensive, that model. And here we did the same type of activity, and we gave it the exact same prompt, but I call it the smart student of the LLM. He doesn't give me just the brand. He has to give me also the model, and I don't want that, right? I just want the brand, right? Smart student giving you more. Okay, so what should we do about it? What we do here is, again, we're going through a process of optimization. And what we do here is we take this same type of prompt, we feed it into this degraded, I called it class A- type of LLM. We evaluate the results. By the way, we're using LLM to evaluate the results as well, which is actually fantastic, right? Because you can get a lot. But we also generate some tools for people to actually look at some of these things, or other software to actually go and understand what's behind it. And if the results are not good, we go back. In this scenario, we went to Gemini, and we said the following. Improve the prompt that I'm about to give you an example for this class A- LLM, and the result that I want you to achieve. So I'm showing you, like, this is what it failed for. This is what I want you to do. And we repeat this until we get to the right place. And this process is like, for us, okay, great, we understand. But then we stop and we evaluate the cost. Because it can still be very expensive So we go back and we might actually downgrade it further and actually bringing a less expensive version of the same LLM until we are happy with the cost. Now, there's some additional tactics that we basically do, and to give you a sense of when you work and thinking about LLMs and prompts, there is somewhat of a relationship between the size of the prompt and the quality of the model, right? So, you know, they're not as good, so you need to be a lot more specific about what you want from it. But when you are more specific, you're going to pay more tokens. So it's kind of like this balance where you have to be like, okay, I'm going to fix that prompt, but I have to be really specific about what I want to get out of it. The second thing we're using is there's something called the zero shot, which is essentially saying, I don't need to give you an example, I just give you an instruction, or one shot or a few shot. And so in these scenarios, we basically give it an example exactly what we mean. So we're saying to it like, you know, isolate parent brand. If a product name contains the word Adobe, right, Adobe Acrobat or Microsoft Office, extract only the parent and tell him exactly what you want, right? So that's helping it to sort of like understand better of what it is and giving it some example. Now, remember that sort of babbling that I got brand and then I got model. Like, okay, so how about we tell it exactly how I want the output, right? And tell it exactly in what format I want to see this particular thing. Am I on time or I'm running out of time? Yes? Keep going. Okay, I'm almost done. All right. So that's essentially the idea, and we balance this and we keep running behind it. Just so you know, here we use what we call the Nova Lite as the 12 times cheaper than what we used before. So quickly, I'm going to shift. We have a lot of clickstream information, a lot of clickstream data that we put out there. The truth is, clickstream is your best view to what's happening in the reality, both in micro and macro level. You're able to determine in all these crazy times which models are actually being adopted. How often are people coming back to AI mode and using it? You're able to tell, oh, ChatGPT came with version 5. Do they actually being adapting? Because we hear in the news, it's shitty, it's bad. But guess what? People are adopting it, and they're actually taking it. Or you're able to understand the modality of interaction behind it, of how many people are uploading their pictures, or how many people are putting files, in order to ask those questions to these LLMs. So it's almost like a compass. And of course, the holy grail, you can tell where the conversion is happening better between Google sometimes and a given model. And so, but when you're thinking about clickstream, I will say to you a few things. There are many, many factors to determine what's a good clickstream. I will just sort of like point out to one particular piece, which is called representation. And representation is essentially the following. If you had a sample of the world, right, and this was the exact representation of the people and what they do and the interest that they have, and that was representing as a 1/10 of the population, ideally you would multiply it by 10. But the truth is, situations are never ideal. Sometimes you have people that are more interested in one information, and so your panel is big and is representative in one area and is underrepresented in another area. So we create something that is called weighted contribution behind topics, and we follow these people along the entire path. I hope you got an idea about what's important for us. We apply these principles throughout. You want to work with SimilarWeb? You can do it on the platform. You can do it on our MCP or our AI Studio. Or if you choose to, you can actually go and build yourself with many of our APIs. Thank you.
Whoa. Whoa.